Liquefied natural gas is one of the hardest fuels to transport across the world. At normal temperature, natural gas takes up too much space to move efficiently by ship, so engineers cool it down until it becomes a liquid. At around -162 degrees Celsius, natural gas shrinks to about 1/600th of its original volume. That means a huge amount of energy can be packed into a much smaller space. But it also creates a serious engineering problem. How do you build a ship that can carry a liquid colder than almost anything on Earth across rough oceans without cracking, leaking, or boiling away? The answer is the LNG carrier. These ships are built in advanced shipyards using giant dry docks, tower cranes, precision welding systems, and thousands of workers. Construction begins with steel. Large steel plates are cut, shaped, and welded into massive blocks. Instead of building the ship piece by piece from the ground up, modern shipyards build huge sections separately, then lift them into place like parts of a giant puzzle. Each block may already contain pipes, cable trays, machinery spaces, and structural supports before it is joined to the main hull. This modular method saves time, but it demands extreme accuracy. If one section is even slightly out of alignment, the entire structure can be affected. Once enough sections are completed, giant cranes lift them into the dry dock, where the hull begins to take shape. The bow, stern, engine room, deck sections, and cargo area are joined together through heavy welding. Inspectors check the welds and measure the structure to make sure the ship can handle ocean forces and the weight of its cargo. But the most important part of an LNG carrier is not the outer hull. It is the cargo containment system. LNG must be kept extremely cold, so the tanks cannot behave like ordinary fuel tanks. They need special materials, insulation layers, and safety barriers that can survive cryogenic temperatures. Some LNG carriers use giant independent spherical tanks. Others use membrane tanks built inside the hull, with thin metal barriers supported by thick insulation. In both designs, the goal is the same: keep the LNG cold, keep the ship strong, and prevent the cargo from leaking into the hull. The insulation system is critical because even a small amount of heat entering the tank can cause the LNG to boil. This creates boil-off gas. Modern LNG carriers do not simply waste this gas. Many ships capture it and use it as fuel for the engines, making the vessel more efficient during long voyages. After the hull and tanks are built, the ship enters the outfitting stage. This is where the vessel becomes a working machine. Workers install electrical cable, pipe connections, valves, pumps, loading arms, control systems, fire protection systems, sensors, and navigation equipment. Every system has to work together because LNG transport leaves very little room for mistakes. The crew must constantly monitor cargo temperature and pressure. The tanks, pumps, and safety systems are designed to detect problems early and respond before they become dangerous. Before the ship enters service, it goes through testing. The engines are checked. The electrical systems are powered up. The cargo equipment is inspected. The tanks and pipelines are tested for leaks. The safety systems are verified. Then the vessel is launched for sea trials, where engineers confirm that it can steer, accelerate, stop, communicate, and operate safely in real ocean conditions. When the LNG carrier is ready, it connects to a terminal through loading arms or transfer hoses. The liquefied gas is pumped into the ship at extremely low temperature, while pressure, flow rate, and safety conditions are monitored continuously. Once loaded, the ship can carry energy across oceans to countries thousands of kilometers away from the gas field. From a distance, an LNG carrier may look like a normal cargo ship, but inside it is one of the most carefully engineered vessels on the planet. It is a floating cryogenic tank, a power plant, a safety system, and a global energy link, all built into one massive machine.